Again, I'll touch on some of the items that Raghu talked about in the user interface so you can see them visually a little bit at the policies, and then we'll jump into a pretty simple provisioning of an OpenStack virtual machine, run some IO through that, and then that'll pretty much conclude the demonstration. So I'm going to go back to the Datera dashboard. As Raghu mentioned, the user interface that we have is actually connecting into the portion of the control plane. I can actually open up another browser window here and change which storage node it is, log into this storage node, and have the same view of data. It doesn't really matter who you hit. We do offer customers the ability to set up a VIP virtual IP so they can have that consistent management point and put it into their systems, but it's not a requirement from the Datera side. I'll go ahead and just close that. From a system configuration, Raghu talked about the various pools. So I'll go to system settings here. When you're defining the Datera cluster, we have a nice user interface to do that. It can also be done in a single JSON file that you can import into the first node, and it'll stand it up and then join the other nodes. You can see here that we look for, here's the access VIP for the virtual IP for the access network, management, no pool data. Now on internal, I've set a pool size of 50 addresses, so I can join 50 clusters, 50 nodes of the cluster. And down here I have my access IP pools. So here you can see the default one is a 172.28, and then I, for visibility, created a secure network. That's a 192.168 space. So the idea is that when we go into the customer's environments, more so for custom environments and folks that are doing larger scale, we could have a number of different layer 3 subnets that those volumes are created and presented to by the LIO layer, all orchestrated by the control plane. And that decision process is made based on all the other constraints of the infrastructure. So, because Raghu talked about it a little bit more in depth, and just to reiterate, we talk about the data services. These spans are allocated on a storage node basis. The storage nodes themselves manage the hard drives and those flash devices. So here you can see we have 12 hard drives. This is the DT5005 with 2 flash devices, high performance NVMe flash, and then it will destage the data based on the tiering requirements in the algorithm. So we talk about the template aspect. I'm going to go ahead and click on my MongoDB template. So you're asking about the iSCSI point, when do IQNs get formed? They're actually formed at what we call the storage instance layer. So within a definition of a storage instance, I can have multiple LUNs. So I mount or log into a single IQN, and then I can have multiple LUNs that are part of that IQN. This particular template has a 10 gig volume with 3 copy. Let me go and show you an example of, say, a Hadoop template. So here what we're looking at is 6 storage instances. So the concept for an Hadoop deployment is we're mirroring what common practices for Hadoop would be, a hard drive or some number of hard drives per box, in this case 6. So if I were to provision this particular template, I would get 6 different disks. Each disk would have a single LUN, 1 copy, 1 replica factor inside the Datera, and the size would be 2 terabytes. But I would get 6 IP points, there'd be 6 different IQNs. So let me just provision this to show that.
While you're doing that, question came in, is the management interface on the box? I'm guessing they mean, is the management GUI running on the actual box itself?
Yes, everything we're showing is on the box. Built-in help is there as well. And when we show the REST API browser, that was in my question, that's all running within the storage infrastructure. So Datera has multiple boxes, it's running on all of them, and you can hit them all and they all behave the same way.
Respond, yeah.
So here we've done a deployment of the Hadoop instance. So in 3 questions, well 2, I was able to provision 6 different volumes, 6 different IQNs, and all the IPs that went along with that. Programmatically, the same thing would happen. If I use Docker or some other infrastructure to say, give me storage for Hadoop, or as part of my Puppet scripts or Ansible scripts that are prepping this new box, get me storage that's Hadoop-like, that all is done. And
your policy there is keeping the physical data separate as much as possible so that you get the wider sort of striping, is that?
So that's a great question, and it's policy driven. So we have two policies today. For a single volume, single copy volume, the data collects on one node because you want to know where it is. Because now you have to map it up to your application tier, which is doing the distribution, someone else's job. If it's more than one copy, then our engine does the distribution across the storage nodes internally. So that's all, as Raghu was saying, that's all policy driven. Today it's under the covers. Maybe someday there'll be a exposure of that.
I mean, to answer your question, the affinity rules drive the allocations of the storage profiles.
Yeah. So here, just to illustrate, you can see we have access IPs and we have a target IQN. And if I click on the next storage instance, access IPs and target IQN. And one of the main reasons for doing this is if you think about a 10, 20, 30 node environment, if there's a failure condition, if I need to migrate, I can move these. I have 6 opportunities to place those disks. I don't have to put them all in the same place, just need to be coordinated about it. The other thing I'll say to Ray's point about having a lot of IQNs, I agree, it does add more, but we're dealing in an orchestrated environment. So if you're dealing with Docker, you never see this. If you're dealing with OpenStack, you never see it. It's all behind the hoods. So the problem is a bit mitigated. We do have as part of the Python SDK, a host tool, which interacts with the API. So you can spin up 40 templates. It'll do all the work for you, so you don't have to see it. But I agree. From a traditional, having worked at other storage vendors that did very well at iSCSI, it is a bit of a difference in the traditional sense. But in the modern era of orchestrated and machine-driven, it's actually not as big of an issue.
Telling me I'm not modern, is that what you're saying?
I think it is.
Don't go there.
Something with grey beards?
You know, Howard's going to be really upset when he hears that because he's watching us. Because he's not modern.
Happy birthday.
So I've switched over to an OpenStack instance. This is, for demonstration purposes, a very simple deployment. It's a dev stack running on a single host. We're logged in as the administrative tenant. We're looking at the overview page. I'm going to navigate to the volume section. Log in again. If I can remember the password. I think it's secret. Okay. I'm going to log into the volume administrative panel and look at the volumes. So this would be as the administrative view and how you set up the volumes. To speed things along, I've done some initial creation. Just a little background on OpenStack. Within the Cinder project, which is Cinder block, the block driver, you have the concept of volume types. So OpenStack can orchestrate and address n number of storage instances, storage deployments. Each one of those would have a type. If I go under the example and do view extra specs, the volume backend name is Datera. So Datera offers a Cinder driver. The primary configuration is in the quote cinder.conf, which is the config file. And that defines the access IPs and other specifications for the Datera system. And now I've told the OpenStack environment that these particular volume types are related to the Datera backend. It's OpenStack. I could actually change it to a different vendor backend and leave the name. Like it's all open from that perspective. You can see I've defined a couple of quality of QoS specifications here, a high performance and in big data, just for illustration. One thing about the Datera is we can support IOPS as well as bandwidth level of QoS. The other thing to point out is the consumer here is backend. Within the OpenStack infrastructure, you can specify a front-end consumer, i.e. KVM or your hypervisor would apply the I/O limits. In this case, we're using the backend on the Datera. So I have my 3 volume types created. Fairly simple stuff. In the description, the big data would be mimicking a hard drive, and the high performance, a 1 gigasecond or 10,000 IOPS. Pretty simple. Any questions about that piece?
So I'm not a massive OpenStack expert, but one thing that I seem to remember is there is a bit of a database mapping somewhere that says what instances have which volumes.
Yes.
And that's kept somewhere. Are you pushing down any of that information onto your platform so that if that ever got corrupted or lost or damaged or whatever, somebody would have an idea of how to map the application back to where it came from? Because obviously with rather sort of generic IQN names, it's a bit difficult to work it out if you lost that.
So when we create the volume itself, the name of the volume in the Datera context is going to be the UUID of the volume. So that will be persistent on the Datera side. It does not include the metadata that's knowledgeable to OpenStack. As a sidebar, this is one area where the OpenStack Foundation has sort of stepped back. They're more interested in infrastructure. Our partners like Mirantis can offer a multi-head node environment where you have full HA, and I'm sure they have backup strategies to dump that database. That's really outside of the scope of a storage system.
Yeah, it just struck me as that if you could store metadata against the LUN, you could just push that data down really easily, and that you just give some people some real benefit with not a lot of effort.
I mean, it's exactly that, and the way we are looking around some of this stuff is that when you talk about intent and everything else, till now whatever I talked about is more about explicit intents, basically, where you're provisioning everything. But where do you draw the implicit intents coming from, basically? Not only from an access perspective and everything. So what we want to leverage is the ecosystem drivers, basically. So ecosystem drivers give us information. For example, today what we want to do, one of the things that Bill and I always talk about is access IPs. How do I know what IP I need to do? Should I place the iSCSI target closer to the application? So what we really want to do is that the Cinder driver has enough information about the Nova host that it's going to use, and it's going to send that information to us as part of provisioning. And then we will allocate a target which is closer to the application. And that's how we plan to do in implicit intents.
But if that provided you the information that said what that instance was, like by name or by ID or something, you could theoretically store it if you really wanted to.
So when the way we have been discussing some of this stuff is again related to the fact that till now storage has been more consumed and used and shown at other orchestrators levels, not the other way around. And what you are kind of alluding to the fact is that can you have a OpenStack centric view within the storage context?
Yeah, basically. I'm just really, like Ray, I'd just like to make sure I know exactly what's what, and I like it a certain way so that if something breaks, I'd always be the idiot. I'd be the unfortunate person who had to go and fix the problem, and I like to just make sure I've got enough information to.
So we are going to have generic label schemes for all the internally. Even though it's a volume, it gets constructed as an application instance, basically. So we have enough label and metadata in the volume that we can stick in some stuff.
Okay.
Yeah. So as Raghu was mentioning, that there's two factors there. We're going to be increasing the opportunity to add tags and so forth. So we could route data there.
Yeah.
The other limiting factor is that the communication between the Cinder driver and us is defined in like the Cinder connector.
Yeah.
So there's limited data there.
Yeah, if they don't give it to you, you're in trouble, Yeah,
and we are working with the OpenStack community and with the Cinder team to put in a number of other enhancements around those areas. So it's a good point, and it's definitely something we'll be adding. So what I'm going to do now is go ahead and create a volume. Very simply, we'll call this one Big Data, because I know what I'm about to do. We'll call it Ubuntu. I'll choose the image source of an Ubuntu image so we can boot it. And then I'm going to choose the Datera Big Data type. We're going to make this 100 gigabytes, and we're going to hit the create volume. So at this point, we're now 100% into an OpenStack workflow. The Cinder host itself will mount the Datera image, pull the Datera app instance. It will take the image at a glance, pour it in, and then detach it. And then when it's done, it'll be ready to use. Just takes a few seconds for that image to deploy. And then at that point, we have a volume from the OpenStack piece called Big Data. If I go back to the Datera and we look at the instances of storage, you can see here that I have an OpenStack instance by the UUID and I should show that a little longer, the icon. For fun, we add a little OpenStack icon as part of the system, so you can tell who created it.
Yeah.
And if we look at the storage settings, we'll see that the QoS setting was mapped in from OpenStack against the Datera QoS. A little bit of I/O happening in the background when it was writing that image. This is really governed by the Cinder system. 100 gigs, 2 copy, which is the default that I have it set for. These things can also be addressed within the extra spec, so you can create multiple types. And we're working to add our template infrastructure into OpenStack as well. So a type could be MySQL, and then that would drive a template action on the Datera side.
So now the OpenStack functionality that you invoked there, automatically invoke the intent
Yeah.
allocation at the Datera through an API? Is that?
Yeah, and so what I'll do is we can go and look at the user activity, and we can see that there is the creation of a app instance, which is our terminology. I can actually view the API request. So this is the JSON package that was used to create that object. So I can copy this, I can put it in my own
So
That's really
as
useful.
prior to that, you already created this OpenStack instance template, I guess, is that?
No, so the OpenStack Cinder driver, so it's part of the standard Cinder infrastructure, is the glue between OpenStack Give Me a Volume and Datera App Instance Storage Instance LUN. And so it's managing and doing that arbitration. So now when the regulated request comes from OpenStack, Give Me a Volume, here are the parameters. We consume those parameters, form that into this API request, and then send that to the Datera. The configuration of what the IP, the login information is contained in the cinder.conf file. I can show that if you'd like.
Now, trying to understand, the template that was constructed on the Datera had to pre-exist in order for all this to happen. Is that?
Yes and no. So to be fair, in this instance, we're just creating an app instance by itself. It's not bound to any template.
Oh.
It's
So
just like an
I
instance.
thought they were all bound to a template.
No,
Not all.
there are two kinds of provisioning. You can always do template-based application instance for scale, or you can do inline the whole app instance as one-off. And that's the technology that we use to convert native volume-based provisioning to directly an instance-based provisioning.
Yeah, so you don't have to have bound instances. Right now, the OpenStack volume infrastructure is not as dynamic as we'd like, so we're working with the Cinder team and have some blueprints in to improve that so that it can work better with our template provisioning. But here you can see from a RESTful API perspective, I now have that volume created.
Make sure we show the REST API as well.
And so what I'm going to do now is fire up just an instance, launch an instance, run a little bit I/O, and then we'll look at the...
You were just showing there, sorry, while you're doing that, you were showing there that you had a JSON definition for the actual volumes?
Yes.
So if you were building a brand new cluster and you wanted to replicate something or
Yes.
do something, you could just
So what we have is an export-import operation. So the way we look at this stuff is that we should be able to take any part of our model that is subset of our data structures
Yep.
and import it to another cluster.
Somewhere
And
else.
that's how you do repeat and mimic all the time,
Yeah.
basically.
Yeah.
So, and that's the beauty of the model-driven stuff is that you apply logical configurations, application templates, and all those things. So the way you do it is you have one data cluster with all the templates defined. You can replicate exactly the same
somewhere
thing,
else.
and you can reduce all your policies to one notch lower level, and that will be your DR site.
Yeah, but it's that, but it's also if you're running 100 locations around the world
Yes.
and you knew you had to configure every single one,
So-
you could give somebody the file and they don't have to get it all wrong and misconfigure
So
it.
that's exactly that was the exact point of the templates and everything else. The way we have always envisioned is that okay, templates are defined by the ultimate authorities, and then rest of them just uses it basically.
Yeah.
Yeah, in the interest of time, and this is a pretty important aspect, I would like to jump to the RESTful API. I mean, I think you guys have seen OpenStack and understand how that works.
Yeah.
So as we showed, the Datera side, the interaction Cinder is driving our API. This is the Datera API browser. There's a couple tabs along the top. For instance, the definition of the various items. We've got the RESTful documentation. So if you have a Datera on site, this is all you really need to operate it. We even wrote a endpoint in the API, so I'm going to log in to get the token, called API. That's not what it's called. The introspection API. So if I execute the GET request against API, I get the API. It's a little meta, but the idea is that this is the storage node verbs that are available. So if you really want to have fun, you can completely automate the creation of your automation system. So let me jump to another aspect, and let's look at the actual system. So when we talk about things like storage nodes, I can query the nodes using the REST API. So if you recall the Datera page, we have the beautification of it, but if you're integrating this with your own on-prem system, you'd probably want to grab this data directly out of that RESTful API, grab the JSON, put it into your own database. that you're doing n-way replication, whatever you need. Here we can also get additional information like what are the IP addresses for the various systems and additional information, the boot drives, the objects, what the UUIDs, additional information available about the various aspects of the system. There's health status is available. As the cluster grows and as nodes come and go, we've changed state. So you might have a 3-node cluster, but you might have 5 objects in the REST API because you had 3 other ones that have come and gone out of that environment. It'll all be tracked and kept in this the API call. And we can do the same for the app instances. So here I'll open up the app instance. We'll not create, we'll do a get. And then here I have the instances. Here's that OpenStack instance. I can find out which storage node it's being exported from by looking at the active storage node. So here you can see that this is the UID of that node. We can also understand from the API what the initiators are and the IP addresses that are being used to export that object. So again, back to your point, from an API perspective, it's relatively easy to create, understand what was created, get that data, and then automate the mount process. So I'm not typing iSCSI-ADM-M node -T IQN and all those type commands.
Do you want to show template instances and actually the code plugins for JavaScript and Python?
Sure. So what Mark is referring to is here on the template side. If I make a request, let me take that back. So application instance, you can see bound to template is one of the options. So we can actually create a new template. First one comes to mind. Did you get that right? Oh. I don't remember the exact endpoint. Do you remember what it is, Raghu? Sorry.
No.
Let's see what the help says. Yeah, you have to get the path. But anyway, the idea is that when you create that, you can actually extract the Python command that was used to do that work, or also via curl. Let's show that a different way. If we go back to the read request here, so if we go to the bottom, I can see the curl, copy that, dump this into my terminal window, and now I have the JSON object via curl. So it makes it very easy to interact with the system and to extract that information. Datera supports a Python SDK, which customers can use in 2 ways. They can use it as part of their infrastructure or leverage how we've used it when creating in their own orchestration. That pretty much wraps up. Are there any additional questions or areas I can show? No?
Right.
I mean, we used to have a platform emulator too, basically, which emulates Datera storage box from an API perspective so that you can just install in a VM, play with the APIs, build up all your stuff. Then you have exactly
Like
your
PSA
configuration. You take a
okay.
configuration from a VM and apply it to your data center, basically.
Okay.
And we have seen a lot of tremendous use case of that because people want to get into the API way before the product is like, at beta time, they want to be ready for, especially the integrators and everybody else with the API.
You don't want to buy a second one when you, just to do the testing of the API.
Exactly, yeah.